Okay, so we're here to talk about observability. So we divide that into three areas, three concepts. One is monitoring, then we have measuring, and tracing. So we class these as monitoring for problems. So anything that's actually wrong with the system, something which requires immediate attention, something that may be a problem now, or it may be a problem in the future. Monitoring is a key part of DevOps and SRE, and this is one of the big drivers for any new DevOps departments. We then have the measuring, and that is closely tied with monitoring. And measuring is tracking things which may not necessarily indicate a problem, but they give you information, metadata that you can use for analyzing behavior, performance, predicting trends, and just having a good overview of what's happening in the system. And then the last one here is tracing, which is a little bit more complicated and a bit more in-depth, but that is more of a debugging and performance tracking tool. And we'll get into exactly how that works a little bit later. But just to quickly summarize, the idea of metrics here is any part of the system that's numeric. So if you can represent it as a number, if it's time, if it's count, it counts as a metric. We also have logging, which is not just numerical. That's where you have a text message or some sort of structured data. And some systems also have a concept of an event, which is similar to logging, but it's to record a specific point in time. The key point of an event versus logging is that with an event, it's a known event happening at a specific time, and you might want to use that to synchronize metrics or to compare, say, between releases. You might have an event that says, I've just released a new version of the code. If the metrics change after that point, then you know that that event is most likely the cause. And then with tracing, we get to link the process flow, see how the parts of the system interact, and identify exactly what's happening throughout the system as a cohesive whole, as a combination, not just looking at single numbers or single messages. So if we start with the metrics, and these are values, numbers, and we can track these across counts, totals. There's histograms where you might want to know a more statistically relevant view. So you might want the minimum, the maximum, or maybe the 95th percentile. So you trim off the highest values and just keep the ones which are relevant. Maybe there's some outliers, temporary network connection problem. The percentiles are really useful for filtering those. In terms of how you implement them is a really simple example. It's Python, but you get similar versions in most languages. You typically have some sort of hierarchy, a structure, and the namespace here is platform.authentication. We're saying that every one of the metrics in here is going to have that as a prefix. And then we've got here a counter, so someone has just logged in, and our metrics collection system can track these events over time. They can make sure that the counts are reset every minute, every hour, so that you can see what your login rate is and so on. Timing is something which records the time between 2 points and is typically represented as a histogram. So you'd want the average, the minimum, the maximum, and other statistical data so that you can see just how much that varies and whether that's increasing over time. And then many systems have something that's not just a single increment. It's not adding one, but it's actually recording the current value. And this gauge value here is quite useful for things like the session count. If you want to know how many logins do you have, how many connections do you have to a server, you can represent that as a gauge. The one potential issue with gauge tracking is that these represent a single value, and if you've got multiple workers, it's quite easy for those to overwrite each other's values. So it's important to get the namespacing, the prefix part, working well enough that you can distinguish between different workers, different components that are all trying to report the same information. So some of these systems do include the concept of a tag. and that will give you a chance to include the worker information. Maybe it's an index, maybe it's the process ID, might be the server, and you can use that to distinguish between the handlers. So that's those. The common metric types. We've covered count and gauge for the current value and timing. Histogram is very similar to timing, but it's more of a generic concept where you want to get a better view of the data over time. And the histogram view is very useful for cases where you have a lot of events and you want to aggregate them, and you want to see just how the variance is changing over time, whether you've got big spikes, whether you've got an overall trending increase. And with just one metric line, you can get all of that information in quite a detailed way. So I think we may have a view of just see if I've got the here we go. Simple view of gauge metric where it's just a single value, and you can see here represented as a line graph. Timing or histogram, here we've just got the 95th percentile and then the maximum, and that shows you that we do have quite close correlation between the two, but sometimes they do drift apart a bit. This can usually be extended to cover things like the minimum, the average, and so on. Single value, quite useful for dashboards. What's our current user count? What's our error count, for example? Those are very handy. And then the histogram information can also be displayed in different forms. So instead of just a line chart like that, you can see the outliers. So here we've got one case where there is a host where I think this is the timing for an API call is much higher than the others. So that looks like it might be a problem. You can use that to investigate. All of these are coming from a service called Datadog, which has been mentioned before. This is one among many. We'll have a quick look at the other ones later. But let's go back to our list. We now get to move on to logging. So metrics, recording the numbers, and we said with logging, that is going to give us the text information. That allows us to record structured data or specific text messages. Can also have stack traces and context. Maxim, want to jump in here?
I wanted to ask you a question regarding logging. So based on your experience, so how do you think where is a best place for storing the logs? Because typically you need the logs when you need to dive in something, and most of the time the logs just saving to some place and are not seen.
That's a great question. So yes, the challenge with logs is they can generate a huge amount of data. You want a system that the developers can access as well as in production. Popular choices tend to be services like Elasticsearch. It's very good at indexing. It's quite high performance, and it can give you metrics as well. It can tell you how many of a certain type of log message there were. And that's also a system which is relatively easy to set up. There's a lot of, for example, Docker Compose or Kubernetes operators which give you a full Elasticsearch or the Elasticsearch Kibana combination. Greylog is quite a popular interface. I see a lot of people using that. Again, relatively easy to set up. People tend to use that as a good way of getting started, especially with the Python stack. One thing that sometimes gets a bit challenging is if you're developing in, say, Docker, and you want to include logging, you just use standard output, you just write it to the terminal. Those systems tend to record the logs quietly for you and not tell you that they've done that. So we've seen problems where Docker's just happily streaming huge amounts of output to the standard output, and no one's actually tracing that. No one's running Docker logs. They don't care about it, and it's quietly filling up disk space while it's doing that. So one difficulty with logging is getting all of the components, sending the logs somewhere sensible, and not having them accumulate somewhere in the system. So again, with Docker, Kubernetes, and so on, you typically want to send those to a service. Again, Elasticsearch is good if you want to host it yourself. If you wanted to make it cloud hosted, I think the standard these days is still Splunk, because they've been doing it for years. They're really good at handling large amounts of data. But Datadog, New Relic, and a few other services exist as well for dealing with those. In my case, where we can, we use Datadog because it's convenient, but it does get expensive. So for developers, we just use Greylog, and that works really well for the volume of data they deal with. I don't know if there's any other systems I've missed there. Any ones that you'd recommend?
I think you named all that are in the trends now.
Excellent. No, fair enough. So I guess yeah, we can skim through what to log. That's always another challenging question. So one difficult thing with logging is that you sometimes find people like to filter out the logs before it reaches production. So in development, they're great because you get all of the stack traces, you get the information, and it can really help track down bugs and improve your code. But logging is something that's actually, where possible, it's good to leave it in the code. If there's no performance overhead, and if you can set the logging level to a sensible amount so that you don't get too much logging traffic and have too much data to deal with, keeping your logging messages in place are really handy, because you might have something simple, like for example here, we're just doing an info message saying the application has started. This case here, it does give you a way of correlating. If you know that there has been a metric increase, and you can find this log line before the metric increase, then it tells you something useful. Those metrics are probably related to a recent deployment or a recent restart. One issue here is that this line on its own, if it's just logging that text message, doesn't really give you much to go on. If you don't even know which application is generating this, it's useless. You might have 100 different applications, and if they all say the same message, how do you know which one's which? So some of the logging frameworks do give you more information. They give you metadata. They will, for example, record the current class name. They'll record the repository if it's running from Git, or the process name, which can be enough to track things down. And it's quite common to have tags such as the host that it's running on, the information about the process ID, or the network that it happens to be attached to. So logging lines like this may not tell the whole story. You may actually have metadata that's injected by your logging framework. So although this one says this is not too useful, maybe it is. It does depend on what's actually processing this log line and sending it to the logging system. We have different log levels, and this is a big challenge to get right, but generally anything that's at debug or trace level, the DevOps team aren't going to be interested in most of the time. Anything that's at warning level may be informative, but you probably don't want to have that enabled by default. Then you have info, which is just a message which doesn't tell you something's wrong, but it tells you something has changed or something has happened. And then you tend to have error, critical, and fatal, which are different levels of severity, but all of those tend to be something that you'd want to record. You'd want to store that in the logging system. There's also the ability to include exception information. Again, this varies by language and by framework, but exceptions tend to be useful in that they take structured data. They will usually have the full stack trace, and the exception is also something that's useful to filter out, because if you've designed your code in a way that says if it's an exception, then it's something wrong, it's something unusual, then you probably want to know about them. there are different coding standards. Sometimes exception could be something innocent, like the client disconnected unexpectedly. You tried to read data, the connection was closed. So it depends on your code. You may sometimes find that recording the exception isn't essential. We mentioned context here, and that's one thing that a good logging system makes available, in that sometimes you have information early on and you want to attach that to any log message that happens. For example, which client ID or which IP address or which server you're communicating with. If it's a database log message, which database? That is something where if you set that at the start, and that can be automatically attached to everything that's in that scope, saves you a lot of time, a lot of repetition. It's something to watch out for in a logging framework. So we mentioned filtering. Make it easy to filter. Hopefully the log levels are enough for that. But it's also important to have messages that make sense. It's quite easy to just put in a message and not really think about it. But it tends to save you time in the long run if you plan your messages ahead and you try and put as much useful information as you can in those messages. I mentioned here sometimes metrics are better than log messages. For example, the client disconnection mentioned earlier. Maybe you just want that as a metric. You don't want it as a warning. You don't want to write a message to the log file. People disconnect all the time. Just send it as a metric. If that number suddenly spikes, maybe there's a problem, but you don't need thousands of log lines or millions of log lines telling you on a daily basis. So the wording here, this isn't a perfect example, but I'm hoping it gets the point across. If you just have a log message that says this, an error occurred, then doesn't really give anyone enough insight to trace it or investigate further. They'll need lots of extra context in order to do something with that. If you can tell it what went wrong, so we failed, and the connection is the issue, the service is a MySQL database on this service using this user, and then we've got the actual failure that happened. Hopefully this is enough for the DevOps team to pinpoint what's going on, investigate and fix it without having to talk to developers, without having to look at code, and without having to go through stack traces. Maybe that's not the case. Maybe localhost doesn't mean anything because you've got 10,000 servers and they're all localhost. But hopefully this is a step in the right direction. So just something to think about when you're doing log messages. Imagine you're the one who's going to have to trace this when it does crop up in production. Just a note here, if you've got a connection refused here, you probably want this as a metric as well. Logline is great, but typically metrics are cheap, easy to send, and give you much better long-term trend analysis as well. Okay, we mentioned events earlier, and they're pretty similar to log messages. The crucial difference is that an event is more of a structured storage. It gives you an ability to say, at this time, this event happened with this data, this information relating to what went on. And events are handy because they are out of band. They're not the same as log messages, so you don't have to extract them from a stream of data. And if you've got a system that supports events, Datadog, New Relic, and Splunk all support these, then it's a great way of doing correlation on graphs. You can filter by a type of event and show that on dashboards so that you can see, for example, exactly when a release happened and immediately see before and after how the metrics were changing. So it tells you something's happened. Much more flexible, tends to be, for example, JSON or a structured data. And it can be used for alerts, can be used for system events, and it's something that is also quite useful for quick searching because you tend to name events. You don't have to do text parsing, you just search for specific event names. Here's a simple example on Datadog for a few different events. These have got metadata that tells it whether it's okay or failure situation, something failed, something recovered, time zone it happens at, and you can do various searching and filtering on these to see how things happen. So once you've got some logs and some metrics, and hopefully you found a way to use events, you now get a chance to put them into action. And that's where the alerting comes in. And this is, we define alerting as communication for problems. Some companies may have a broader view of alerting. They may treat it as not necessarily a problem, but something to celebrate. And I guess alerting is one of the most important parts of the active DevOps team. So Maxim, do you want to step in there?
Yeah, wanted to ask you a question. So yes, you are right that alerting is very important, but from my experience, we create tons of interesting alerts, and after some time, there are rules that just follows and redirects these emails or some other kind of notifications to the bin or to the trash. So how do you think, what is the best way how to create the alerts that will be read and not redirected to the recycle bin?
Yeah, that sounds very familiar to me. We've had plenty of problems with that in the past. We've had cases where the alerts go to email groups that are no longer active. We've had cases where people mute or they just put in email rules to divert them. One thing that really helps with alerts is to have a clear, well-defined process about making alerts actionable. So as part of the alert handling, you'd want to make sure that every single defined alert has a process that you know what to do. So you don't allow anyone to add an alert to the system without putting in place a process to go with it. That may seem a bit over formal. I mean, some companies they don't work that way. They want the flexibility. They want to encourage people to add alerts for things that are suspicious and be as proactive as possible about monitoring the system. But even if you don't have a process like that, having a post-mortem process for alerts, a follow-up where after an alert happens, you review the next day. So most systems give you a way to just look at the history, say the last day, the last week, and get a list of the alerts that happened, the count of them, and just go through them, just filter them out and say, did this actually lead to anything useful? And if it told you something, but you couldn't do anything about it, then that's usually a good sign to turn the alert into a dashboard or a report or some form of log message, which would be available for later. So different companies have different approaches. If you've got alerts which are just going to email, then it's quite easy to ignore them. So that's where the other trick we find for making alerts useful is that you don't add an alert unless someone gets an active notification. So not an email, but a phone notification or a call. We use a service called PagerDuty for notifications like that. And if you've got alerts which don't have those set up, they get flagged for review. And if no one wants to be called, if they don't want to have that real-time notification, it shouldn't be an alert. It should be just an out-of-band email. One thing with alerts is that they can be used for telling you that something good happened. So people do sometimes abuse them for reports, like we've just hit our 1 millionth customer. But I think that's a comparatively rare problem. So in terms of the alert content, we find that it's quite easy for someone to add an alert and it ends up being something went wrong, and that's it. It tells you like this server is down and you have no idea what the impact is. So you have to go and look up what's that server used for, what services are on it. So we've come up with a few rules. We don't have a standard template, but we do have rules where any alert has to include what broke, who does it affect, who can fix it, and that helps. Hasn't solved the problem completely. So we do get our fair share of alerting problems over time. Am I missing anything on alerting in general? Is there like any way of alerts getting to people that I might not have covered there? I think Slack and other systems are quite popular as well. I didn't mention those. So yeah, having it pop up in a public channel also tends to get a bit of attention.
Yeah.
So
Thank you for sharing your experience, and I think that now, beside the fact that we need to set up alerting, we need also to make our documentation and our process up to date and working.
that's it. I mean, it is a challenge, but it is really worth the time. And even if you just have a process of review, right? Anytime something broke, review it afterwards. Things improve over time, and it's the type of thing which needs to be communicated as well. This is perhaps going a bit off topic, but the feedback cycle of developers, the QA process, and the DevOps team, making sure that problems that happen at the end of that get well communicated to the developers, and tends to help a lot. I've got a few notes at the end about why metrics can be useful for developers as well, but that cycle we find is really important. Let the teams talk to each other. So while we're on the subject of alerts, here's an example of an unhealthy looking system where we've got a list of 3 services there, all triggering alerts all over the place. This is an example of something with thresholds configured a little bit too strictly for some services here. So there is a graph in about the middle of the page here showing that we are just going over the I think it's the timing threshold that we set. In this case, we weren't sure what the average value was, so we set up some alerts and left it running to see, what the pattern would be over the course of a few hours. And the advantage of having alerts can be seen through the section at the top where you've got clear color coding, where you can see at a glance roughly how much of the time the system was down. We find this useful for SLA and other dashboards where we want to show just how well the system was working, were we keeping to our targets, and are there patterns. You can see here we've got 3 rows, and they're pretty similar. The bottom one is showing a slightly shorter outages and slightly more of the red ones, but you can see that all 3 of them tend to be failing. If you had cases where there was just one that was failing and the other 2 were fine, that tells you maybe you should be looking at just that server. If it's all 3, maybe it's the code that's wrong. Maybe it's something to do with the network or something that they are communicating with. So again, this is from Datadog. New Relic and Splunk have similar views, and they also give the chance to look at the history, the time frame. Bit hard to read there, but that's just the last 4 hours. You can usually go back a few weeks, see trends over time. So there's alerts and so on, are all very exciting, but we can dip back into the development side of things. So if you've got any questions on those before I move on, let me know. Otherwise, we've got a slightly different topic now. So tracing is slightly rarer. Most people have used logs. I think metrics are familiar to pretty much everyone, and I think alerts are also not particularly unusual. Tracing is less popular. The tools have evolved a lot over the last few years, and it is actually quite a deep subject. There's a lot that you can do to set up comprehensive tracing on a system. But the basic concept is that it's giving you a way to visualize application logic. You can see a single request or a single event and trace that through not just one system, but distributed systems. And especially in a cloud environment like Google or AWS, being able to see how the services interact and which parts of the system that moves through gives you a lot more powerful tools than just numbers, just metrics, where it's a black box. You have a graph, but you have no idea what actually went on behind the scenes. Let's quickly go through just what tracing looks like in code. And in this case, I think Python again, you've got a scope here where all of the content in there is grouped together as a single span. You're recording one log message there, doing some handling here, and then we've got an exception handler. We covered using exceptions as log entries, and here we've got just some basic context information. Sorry, let me go back again. Then at the end of this, we actually have a raise to rethrow the exception. So we just record the message, but make sure that it does go back up to the top level handler. And the idea is that all of this is within something called a span, and this groups together the log information that we're recording here, any exception if it happened there, and it's recursive. It happens within this process request as well. And anything that calls, again, would be sending it as part of this top level span. Those are grouped together and you end up with this hierarchy. And this is for example, a request here, the top level parent span. Something which happens within that, for example, a process request there could be that first child. Maybe that's made a database lookup, so that would be the next child under that. Any log messages recorded under those will be attached to the span. And when you do make, for example, a database lookup, you can also pass information, an identifier, over the network or to an external system and have that record information that's attached to the top level. You put all this together and you end up with the ability to see a graph of just what happens step by step through request processing. Let me see if I can give you an example on that. Here we have a tool called Jaeger, which is probably familiar to anyone who's used the Prometheus all-in-one packages like K3s and micro Kubernetes. You tend to get this available as an easy install. It's also got its own operator on Kubernetes, but this is an example network service. So a simple web app that allows you to trigger various things. And that web app has some database operations and some Redis cache operations. And you can see the breakdown at the top, very similar to the Chrome debugging inspection tools. You've got this initial top level here is an HTTP GET request, which is what started off this request. You can see what the method was, that it was a GET, that we returned a 200 code, what the URL was. All of this metadata is just attached as part of the request handler. So the HTTP framework gives you this information. But you also get to associate the logs. So any of those log lines that you added, this top one here, HTTP request received, that comes from the HTTP framework. Getting customer is from your application code. But they're all just combined together like this. And you get to see all of the log lines attached to the request. In a normal log parsing view, all of the requests from across the system will be intertwined. You will see the requests, especially in asynchronous code, all being mixed up, and it's quite hard to trace the traffic. With this view, you get to see everything here, and it's guaranteed to be specific to this request. So even if other requests were being processed at the same time, say something happened 20 milliseconds in between here and here, that gets filtered out. You just see the relevant information here. Again, you can expand these out. There's metadata using the context handling from the logger. So all of this is building on the existing logging features that we've already covered, but giving it to you in a way that's specific to a request, specific to one action in the system. This extends to things like SQL queries. So you can see here we've got one simple SQL query where doing select style from customer where customer equals ID. Again, logging here, you can see that there's a database log being attached there. Redis, caching information here. We've got information about what the request was. You've got all of these are in order of where things happen. So on the right here, you can see the progress through time, and we see some of these are failing. So error equals true, got some log message, and here is a Redis timeout. So this gives you quite a comprehensive view for requests, and you can usually search by various tags, things like the database queries. Show me all of the requests that got a database query. Let me see a dispatch one there. Here's the view. These all had some database activity. And one other thing this gives you is the ability to look at what it calls the system architecture. As a free tool, the UI is a little bit primitive, but here you've got the components. You can see them interacting. The text is really small, so it's quite hard to read, but they do give you a slightly clearer view. Where you can see the top level component here going to a root microservice, a customer microservice, a driver service. And each of these have got, for example, here we've got MySQL, here we've got Redis. So this is a feature that makes it really useful for identifying what went wrong with a specific request. It is quite resource intensive. It does have a performance hit, but as a feature where you can turn it on in your production platform, it's invaluable in tracing specific details, like a particular client is seeing problems, or one particular area of the code is problematic. So that is it for tracing. One thing about tracing is that there is a standard called OpenTracing that covers the logging, and it covers the views you saw there. There's a newer standard, and that's called OpenTelemetry, and that is something which is giving you the metrics as well. And if you look at the OpenTelemetry site, they have plenty of good examples of just how you can use it and what it does. But the big thing that OpenTelemetry adds is the concept of metrics. You can bring in the metrics here and see that in that same view. So they recently released version 1.0, which is hopefully going to be available in language frameworks a little bit more widely. But that brings together all of the things we've discussed into one view. So it's a big improvement. That was tracing. Let's go into a slightly different topic now, which is the dashboard, which is the view that most people have when you talk about metrics. So a dashboard, pretty simple, combining information from various sources. Dashboard can look like this. We've covered most of these concepts already. We've got you can see the line chart there. You can see the errors over time, values like this. This is from one of our Cloudflare service tracking things. Maps, quite handy if you want to see a heat map of where activity is, and you also get things like events like this being shown so that you can drill down and see what's going on there. Dashboards are really important. They are a very broad subject, and making a good dashboard is a work of art. It's something where it's quite a challenge to get the right level of information, but it is what most people think of when it comes to metrics. So I'm going to quickly run through just how to get things in, because we've had a look at some code. We've covered kind of what things you can get from metrics, logs, and the tracing. But how do you turn that code you've added into something which is actually giving you the metrics in a system? So we've got two pieces. Instrumentation, that's the code that we're adding. That's the log lines, it's the metric lines. And that's something you add to your own code. when you're dealing with existing products like databases or cloud services, then there's integrations. They connect to those, they pull the metrics, and they give you information from those systems. With those, you need to put them somewhere, and there's a few options here. Before we go into the options, there's two ways of getting metrics into a system, and this can be quite a non-obvious topic, in that you can either push metrics to a system or you can pull metrics from a system. Pushing metrics is where you have a line that says send this metric to a system, and that will either immediately send it or it will queue it for sending and actually be proactive. It will make the data get into the system. So typically it happens as soon as they're generated. With StatsD, for example, that's a UDP send, and it will just push the number immediately when it sees that line of code. UDP is good because it's no connection overhead, typically doesn't have any blocking or other issues, and if it fails, you don't really care too much. I mean, you'd like to know if it fails, but you don't want to stop whatever you were doing. With a push-based system, you're much more likely to get everything up to the point where the code crashed. So if you had a send just before you had a segmentation fault or an unhandled exception, or the service ran out of memory, then with a push-based system, you're very likely to have all of the metrics leading up to that. That is a slightly older model. StatsD used this, which used to be a really popular system by Etsy some years ago. The other side of things is the pull-based, and as the name implies, you're collecting things and then you wait for someone to ask for those. So it's very common to have that using HTTP. You expose an endpoint, you listen for requests, and there's a concept of a collector, which is a service or a sidecar, which will pull. It will request that data, and so this is useful in that you can use that endpoint. If it's HTTP, you can just do a GET request, a curl or wget or similar to pull the information. Really good fit with things like the Kubernetes health checks and liveness checks, because that concept is available in most languages. You just have an HTTP endpoint. Prometheus uses this as its main system. There is an adapter. You can use StatsD with Prometheus, but Prometheus by itself, the collector expects the HTTP requests. If you've used Golang, there is all the Go statistics tend to be available, exposed, like the garbage collection and so on. That is quite easy to just have the asynchronous HTTP endpoint running all the time. Push and pull, you get to choose your system. You can mix and match, but once you've decided how you're going to get things into the system, you actually need somewhere to store the data. We've looked at Datadog, so I'll just skim through the features quickly. We have looked at the actual graphs and the alerts there, but it does actually cover a few other things. The APM, you can possibly see from the graph here that it's a slightly nicer view compared to the Jaeger tool, the open source one that we looked at. It has a similar concept for the client side called real user monitoring, and that is something that happens in the browser. You can have this information from mobile or web applications. Again, similar information, tells you how long things took, and it's quite a good way of coordinating your server side with your client side information. They do also have various security tools for monitoring. They've got agents that run on servers and look for suspicious behavior, and it works in the cloud as well. They use eBPF, which is a very advanced system. You can have a very high performance rules configured that run similarly to the way things like IP tables and X tables work. You can also do CI/CD results. So if you wanted to have everything in one place, single pane of glass concept, maybe you have a CD pipeline for deploying your code, and you want to see where the failures were, why they happened, how long it took. You can integrate that there. Then You get other systems which are very similar in feature sets. Typically, they have a few key focus areas. New Relic likes to compete on price. They are purely based on data volume. They used to be more focused on the logging side of things, but New Relic, I think, supports pretty much every feature that Datadog does. I'm not aware of anything that's significantly different between the two. And then Splunk, which is more of a logging system. They were very much the standard of high volume logs, but they've introduced metrics. They've got pretty good dashboarding features as well. So there's actually quite a few platforms to choose from these days. And then you can host it yourself. So self-hosted, unfortunately, with open source and free options, you have to do a little bit of construction and integration yourself. But you typically have a collector or a series of collectors which store into a time series database. So Prometheus is a very common one for Kubernetes. The system tends to look a little bit like this. You've got the storage in the middle bit here. You've got various jobs and exporters for gathering things. These are all pulling metrics in from various sources. Then you send alerts out through various systems here. But this is all just storing things internally. I mean, Prometheus itself, the interface is not very user-friendly. You can see here it's we're looking for one particular query, memory stats from Go, and you've got this text line here with a number here, no graphs, no views there. There's basic graphing features in here, but when it comes to dashboards and anything else like that, you're going to need to go with something a little bit different. Victoria Metrics is relatively new, quite a nice system. I'd recommend having a look at it. Very high performance, again, a time series database, good replacement for Prometheus. InfluxDB, sorry, wrong picture there. InfluxDB is the another time series system, and the InfluxDB has got its own database, its own way of storing things, and it is very fast. It's nearly real time. Good integration with most languages, so quite a popular one these days. And StatsD is really good if you want something simple. Just grab it off GitHub, run it up, and things just send data through UDP, and you can even just use TCP dump or network tracing to see the events come through. So for developers and debugging, StatsD is often good enough. When it comes to UIs, Grafana is probably the most popular. It's a free service with enterprise and other options, but Grafana gives you various dashboards, not quite as effective as, say, Datadog, New Relic, and so on, in terms of usability. But it does have all of the views. You can do graphs, you can do tables, you can do text blocks to show information. So the other option here is Chronograph, which is supported by the Influx team, and they give you a good alternative to Grafana. It's not quite as stable yet. I mean, Grafana looks like this, simple kind of graphs and things, but you can see the interface is more noisy. There's more complication on here compared to what was in Datadog. The Chronograph, I don't have an example for that, but it is slightly nicer, and I think it's more actively developed these days. That was the systems. I'll just finish off with a quick overview of how metrics can be used. So when you're developing code, logs everyone knows about, everyone uses logs. They're worth keeping in because you can just turn them on and off. As long as you don't have a language where there's a lot of overhead when you leave logs in. Logs also, they complement comments. You can have them in the code disabled by default, and you can see how the flow of the code works. Metrics are useful for developers. May not be obvious, but with metrics, you can use this as a way to link systems. If you have your test code listening for metrics, if you have it working using the way StatsD works as a UDP listener, you can have distributed services sending metrics to your test cases. If something only picks up data every 30 seconds, for example, instead of sleeping for a minute to hope that you catch it, you can just set up an endpoint and wait for the metric to come in that says, I just loaded that data. Tracing is also really good if you've got a massively complicated cloud system and you want to see how it works. So if you've just joined a team and they use tracing, they use OpenTracing, enabling that and then just making a few requests and seeing the architecture diagram draw itself for you is a really good way of just seeing just which parts of the code should you be looking at. QA team also benefits from all of these. The challenge for QA is finding new and exciting ways to break things. So with QA, you can check to make sure, did the metrics pick up a problem? Do the dashboards actually tell you there's a problem? Do you get the alerts? And as part of the development process, if the QA team can insist on the errors being something that they can trigger, you end up with a more robust system. I think DevOps and SRE, probably quite obvious, tend to be what most of the metrics aim at. You can also monitor the activity. You can use it for long-term planning. It's not just historical. You can, for example, you can look at trend lines and see when will we run out of space. If you're going to run out of disk space within a month, maybe it's time to order some more or expand some servers. And tracing, again, really useful. If you can enable that in a production system, very powerful concept. Business can benefit from the metrics. Maybe they're not so interested in logs, but live metrics and dashboards, really good for business information. You can use those metrics for big data and similar. And that's pretty much it. Thank you very much, everyone. Do we have any questions?
Thank you, Tom. It was a nice dive and overview of monitoring tools, approaches, and yes, we have questions. So we fixed our quiz and we want to launch it now. And while it will be working, we will answer the questions that we get from our audience. So let me just open the list. And the first one, I think it will be interesting because this tool was not mentioned by you. Also, Maxim asks, what about getting the logs, aggregating the logs with Loki, and then sending them to Grafana? What cons do you see in this approach?
Yes, so that's a good question. There are various ways of shipping logs through systems. We actually use something called FluentD for gathering and sending logs. One thing I'm not too familiar with is Grafana as a logging tool. I've always used Kibana instead, and I think the logging's relatively recent in Grafana. So I'm not an expert when it comes to like the features or pros and cons there. One thing I would say is that having the logs and extracting metrics has been a feature that works quite well with Grafana, because if you've got a logging pipeline that's able to extract information, that's a really good way of populating metrics without having to add metrics all over the place. So yeah, in terms of using logs directly with Kibana, I'm not too familiar with whether it's good for high volume, whether it handles that well, or whether it starts to struggle with that level of detail.
Okay, thank you. From my experience, if you use Loki, you need to firstly understand what shipper will you use for it, because not all the system is supported. Let's come to the next question, and it is related to the Datadog. So Alex is asking, how did you overcome the limit of Datadog? Because in the main, it is filtering the records by time. How could you make the visualization based on the value change? Not always the last change is the maximum.
Right. So for the metrics, Datadog's, unfortunately, it's not always possible to get what I would call accurate views of the data. One problem we do run into quite often is that the different aggregations across different spans of time will give you different results. So there are some agent configurations you can use to change the way things are aggregated. But in terms of giving you the most recent data, the current value, the closest we found is using the gauge type and sending that with appropriate tags, and separately also sending data using the timing or histogram metric. So it's the same value sent two different ways. And we find the gauge one has been more accurate if you're careful about tagging. So no part of the system can send that same value twice. If you have two workers, it just doesn't work. But if everything is unique, then the gauge value is more reliable. It's not quite real time, but it's usually within 2 to 3 seconds that the value is visible. I don't know if that matches with anyone else's experience, or if there's a trick that we haven't come across for getting accurate information.
Okay, understood. And I forgot to mention one more thing, that you will need to select the most interesting question, and we will give a prize to the author of the question. So let's move next. I think that I saw one more question regarding the Datadog. Yeah, I'm not sure that you could answer this question, but anyway, how much do you pay for using the Datadog for logs, and what are the tiers? Can you name some numbers to understand the context?
Yeah, so that's yeah, that is a good question. So in terms of Datadog pricing, they at scale they will give you a bit of a discount, but the logging information is we've had to trim it down. We don't send nearly as much log data as we would have liked to have done, and we don't use it for QA and development. Having said that, they're actually really good at if you have something which goes wrong and it sends a huge amount of data, either for metrics or for logs, then they're actually quite good at fixing that for you. You might find, for example, we were generating a new metric key for every single metric send that we were doing. It was putting a memory address in there. So instead of our limit, we were orders of magnitude higher than the target amount. So the bill there would have been excessive. I mean, it would have been very high. But we only have, let me just check. At the moment, we have 270,000 log messages across the last, since the start of November, which is probably quite a small value compared to teams who are trying to log all of the debug and trace information as well. And in terms of how much that costs us, it's all combined as part of the sort of overall metrics and pricing. But we find that we're paying on the order of about, it's less than $1,000 for all of the logging parts. Most of the cost goes into the metrics, and the metrics themselves, they tend to be something that can quickly grow out of control. So that may be surprising. It's not logs that cost us the most money. It is literally the metrics there. Datadog, I think, is slightly different in pricing compared to New Relic. New Relic is purely on data volume. But the log pricing, they do give discounts. Unfortunately, they don't give massive discounts until you're getting to really big numbers.
Yeah, everybody likes discounts and everybody likes the concrete numbers. Thank you for sharing. Next question. It's regards using logging solutions in Azure. So Pavel asks, why not to use a standard ELK cluster solution on the images in Azure? Do you have any experience in that?
Yeah, so okay, that's a good one. So the ELK logging is a fine solution. I mean, the stack is quite easy to set up. It's a little bit more troubling when you have to expand the cluster, when you've got a huge amount of data. But one advantage of ELK is that it's something you can deploy in development. Anyone can run it on their laptop, and that means that it encourages developers to use it. So in terms of is anything wrong with it, I'd say quite the opposite. I'd encourage using that unless you want the full integrated platform that you get with, say, Datadog or New Relic. So the ability to see all of your metrics, all of your web browser tracking, the events, the CI/CD events, the information from the process overview. One feature that Datadog has, which I didn't go into due to lack of time, is that they give you the ability to monitor processes, like see exactly what's happening across the platform. You can bring all of that into a single page. You can load it into a notebook and just see what processes were running an hour ago and what log messages were related to that. And that's quite hard to get with just ELK on its own. If you're just doing logging, it's a great solution. It's the integration that it's a little bit lacking in.
Okay, thank you. Next question. I think very interesting for the audience. How to detect that I cooked monitoring logging wrong?
Okay. How to detect that the logging monitoring is wrong?
Yeah.
Is that?
How to understand that the monitoring that you have established is wrong?
So the easy answer there is that the QA process would cover the cases where this scenario is working, and you know that it's working because you've gone through and done the steps correctly, and then you repeat that by deliberately making mistakes, like you go to error pages, you restart services, you crash the database, you delete data, and you make sure that the monitoring that the alerts and metrics are triggering. That's a bit of a lazy answer, though, because you can't rely on a perfect QA process. You often have monitoring and logging and other things which are done by many different teams, and it all ends up in one central place. So what was working in isolation, one specific development task, may end up conflicting with other ones. So one thing I would suggest there is actually doing tests in like the whole disaster recovery, goes through and check to make sure that the alerts do trigger. The monitoring don't rely on just one piece of information, but cross-check. Have, for example, log messages recording metrics, as well as information directly from the gauges and histogram metrics, and make sure that they match. Check trend lines over time. If you know that one part of the system has increased load, then that you would expect to have similar patterns elsewhere. So define not just simple monitoring on individual pieces, but have correlated metrics where you combine information and look for those as well. Some of these platforms do have a machine learning AI aspect to them, where they can look for outliers. They can flag cases where things are perhaps changing in a way that wasn't expected. They do take a lot of tuning, but those can be helpful if there's something you've done which has broken monitoring, and if you've got a threshold where it goes above a certain amount, it should trigger an alert, and that metric is no longer being generated, so it drops to zero, threshold never triggers, you don't know anything went wrong. The anomaly detection, the ability to see unusual patterns and flag those, can be quite helpful for identifying that. But the method we use is regular review on the dashboards, on the alerts and the monitoring, and make sure that if something hasn't triggered for a few months, it's time for a disaster recovery test. If the dashboards are showing numbers that haven't changed, then investigate those. If anything's empty, if we've got a graph which is no longer populated, or if we select a host and it's showing no data, something went wrong. Maybe someone switched off. Maybe it's been maybe it's crashed and there's a problem. So it's not a single answer. There's quite a lot of different factors working together. But I definitely agree. It's an interesting challenge, and monitoring, meta monitoring that your monitoring is working is it's quite an advanced subject in itself.
Yeah, you need to monitor what you are monitoring. Okay, and last question from Hannah. Do you prepare special policies for descriptions for errors? For example, documents with patterns for developers, how errors in application should be described?
Okay, so I would like to say yes, we've got really detailed information on how to do that, but sadly, no. What we do have, we've got our coding guidelines, and we have some examples there. We do try and cover the concepts. We try and explain the things to record. And we typically go for the, we call them the 5 W's. It's who, what, where, when, why, and sometimes how. Doesn't always work, but if you can flag who should be notified, or who does this affect, what went wrong. So it's not just an error, but an error doing what. Where, which piece of code, which component. When, hopefully from the timestamp, but there's also the concept of what caused it. Is there a specific combination of data which triggered that? So we are not as organized as having a template or a standard pattern that we fill in. Some companies do have structured logging, where they actually have a JSON data structure where you have to fill in each of the components. So you don't just have a plain text message. You have all of these keys that need to be populated. We find that actually doesn't work so well because we have a range of different experience levels, and if people are spending too much time trying to get the logging right, it tends to affect productivity. It's also not great for morale. If people keep telling them, no, your logging is wrong, then it's sometimes it puts people off even doing the message in the first place. They decide, I just won't bother logging because someone will complain about the message I created. So we try to go for more of a make sure you trigger all the log messages and then get the teams to review them together to decide, did they make sense? Did we get something useful? And the last problem there is that English isn't the first language for most of our company. So if we say all the log messages have to be in English, it's a bit unfair to say, well, it's got to be perfect English, it's got to be really clear. Yeah, bit of a challenge there.
Great, thank you for this detailed answer. And now is the most difficult part. Need to choose the most interesting question. So, do you have any candidate already?
Excellent. Okay, so I would say, I mean, it's a good collection of questions, and covers the topics quite well. I think the monitoring of the monitoring just wins out, and I'd give the runner-up to the Datadog one. Actually, knowing about the quirks with Datadog's values, I think deserves special mention. But definitely, monitoring the monitoring is one of the biggest challenges, and that's should be top of anyone's list.
Okay, understood. So this question came from Andrei Kazantsev from YouTube. Andrei, if you are not the member of our Telegram channel, please join so we could reach you and give you the prize.